I'm Shraddha from CSE Department Section F. My AAT topic is second order non-homogeneous equation. So, firstly, the second order non-homogeneous equations are the differential equations of the form double differentiation of y plus px of differentiation of y plus qx into y, which is equal to gx. Gx is a non-zero function which is on the right hand side of the equation. These equations are also used in solving problems in physics, engineering, biology, and also in maths, obviously. Next is the standard form. The standard form, as we have previously discussed, the standard form is uh, double differentiation of y plus p of x into y dash plus q of x into y is equal to g of x. The standard form of second order non-homogeneous equation is crucial for analysis. It allows us to separate homogeneous part from the non-homogeneous part. The general solution consists of the complementary solution plus a particular solution. Homogeneous solution. The homogeneous solution is found by solving double differentiation of y plus p of x into y dash plus q of x into y is equal to 0. Here g of x is equal to 0. So the solution will be having a homogeneous solution. This homogeneous solutions are of three types, where the roots are real and distinct, where the roots are real and repeated, or complex. This involves finding the roots of characteristic equation associated with differential equation. The particular solution y underscore p, which is basically defines particular solution, is needed to address the non-homogeneous term g of x. Various methods exist to find particular solution, including the method of undetermined coefficients and variation of parameters. The choice of methods depends on the form of g of x, which is a non-homogeneous equation, non-homogeneous part. This method is effective for the polynomial, exponential, sine and cosine forms of g of x. G of x can be in the form of polynomial, exponential, sine and cosine forms. It involves assuming a form for particular solution and determining coefficients by substituting back into the original equation. It is essential to ensure the assumed form does not duplicate the homogeneous solution. Variation of parameters. Variation of parameters is a more general method applicable to continuous function of g of x. It involves the solutions of homogeneous part to construct the particular solution. This method is particularly useful when g of x does not fit the standard forms. General solution. The general solution of the second order non-homogeneous equation is given by y is equal to particular solution plus complementary solution. Here the complementary solution is represented by y underscore h and the particular solution is represented by yp. This structure allows for a full representation of a behavior of the system described by the differential equation. Examples of non-homogeneous equation, and an example for second order non-homogeneous equation is y double differentiation of y minus 3 into differentiation of y plus 2 into y is equal to e to the power x, which is basically, here the g of x is e to the power x. This is an exponential form. Another example is double differentiation of y plus y is equal to sin x. Here g of x is sin x, so g of x is in the form of sine, which is a trigonometric non-homogeneous term. This second order non-homogeneous equation is also used in physics. Second order non-homogeneous equations model many physical systems such as damped harmonic oscillators. The non-homogeneous term often represents external forces acting on the system. Understanding these equations allows for predicting the system response to various inputs. The second order non-homogeneous equations are used in solving the equations in harmonic oscillators problems. In this harmonic oscillator equations, this non-homogeneous term is represented by external forces acting on the system of harmonic oscillators. Understanding these equations allows for predicting the system's response to various inputs. This second order non-homogeneous equations is also used in engineering. In engineering, such equations are used in structural analysis to determine deflections under loads. They can model heat conduction and diffusion processes in materials. Engineers rely on these equations to design systems that withstand external influences. In engineering, uh, structural analysis is done where this second order non-homogeneous equations are used to determine deflections which are under load. They can model heat conduction and diffusion processes in materials, which is also physics, but in engineering it can also model heat conduction and diffusion processes in materials. Engineers rely on these equations to design systems that withstand external influences. Numerical solutions. In many cases, analytical solutions can be difficult or impossible to find. Numerical methods such as finite difference method can be employed. These approaches allow for approximate solutions in practical applications. So, the second order non-homogeneous equations, when solved numerically, uh, finite difference method gives approximate solutions in practical applications. Applying this non-homogeneous second order equation in practical gives us approximate solutions, but analytical solutions may be difficult or impossible to find. Software tools. Various software tools can assist in solving second order non-homogeneous equations. MATLAB, Mathematica and Python libraries such as SciPy are commonly used. These tools provide both numerical and symbolical computation capabilities. Challenges and limitations. One challenge is ensuring the correct identification of form of g of x for particular solution. Non-linear terms may complicate the solution, requiring different approaches. It is also important to validate solutions against boundary conditions in practical problems. First, we need to identify in what form g of x is present, whether it is in homogeneous form or non-homogeneous form, before starting to solve the problem. Non-linear terms may complicate the equation, requiring different approaches. It is also important to validate solutions against boundary conditions in practical problems. To conclude this, second order non-homogeneous equations are fundamental in various scientific fields, as we have already discussed. Uh, in scientific fields such as physics and engineering, this second order non-homogeneous equations are used. Mastery of methods to solve these equations enables better modeling of real world phenomena. When these second order non-homogeneous equations are applied, it helps us to solve equations better in real world. Continuous study in this area is essential for advancing knowledge in applied mathematics and engineering, as we have already discussed about this applications of second order non-homogeneous equations in physics and engineering. In physics, it is used to solve the equations in harmonic oscillators, where the non-homogeneous term, which is g of x, represents the external forces acting on the harmonic oscillator system. When this equation is solved, we get the values. These equations allows us to predict the system's response to various inputs, and in engineering it is used to model heat conduction and diffusion processes in materials. Engineers rely on these equations to design systems that withstand external influences. In engineering, such equations are used in structural analysis to determine the deflections under loads. So, second order non-homogeneous equations are also used in software tools such as MATLAB, Mathematica and Python libraries. In Python, this second order non-homogeneous equations are used in libraries like SciPy. These tools provide both numerical and symbolical computation capabilities. Various software tools can assist in solving second order non-homogeneous equations. These are the few challenges and limitations of second order non-homogeneous equations. Here, the correct identification of the form g of x is a little difficult. To know the correct identification, whether it's homogeneous or non-homogeneous, Conclusion. This second order non-homogeneous equations are fundamental in various scientific fields. Mastery of methods to solve these equations enables better modeling of real-world phenomena. Continued study in this area is essential for advancing knowledge in applied mathematics and engineering. So this is my idea on second order non-homogeneous equations. Thank you.